Okay, good afternoon. Sorry for the little technical glitches there in the beginning with the restart of the timer. Uh, had some odd behavior with my computer this afternoon, but we're good now. So welcome to the second episode of Graph Guy. I'm Clark Richey, and I'm the Graph Guy. Last week we gave a bit of an overview about graph databases. We talked a bit about the difference between RDF and native property graph databases, and explored that in some detail, talked about some pros and some cons, and as I am wont to do in this stream, gave my personal opinion on both of those. So today, we're kind of going to go to next sort of logical step, and we're going to talk a bit about data modeling for your graph. And as we do that, I'm going to try to construct sort of a handful of generalized rules for that, and we'll talk about those, and we're going to talk about the importance of modeling, and that's, I think, where we're going to start off with, is the real importance of modeling. And I'm going to start with perhaps the somewhat incongruous statement that when we're developing technology and technology solutions for people, for customers, for businesses, the sad but true fact is they don't care about our technology. Right? They don't. They only care about solving the problem that they've paid us to solve. And they really don't care if we use a graph database, or if we use a relational database, or if we use, magic gerbils that are riding around and flying bananas. They don't care. And nor should they. It's about getting the job done. And to that end, in my view, the data model and coming to a mutual understanding between the engineering team and the stakeholders, the customers, right? The people who really, really understand the problem domain and need us to help them develop a solution. That's the most important part. If we don't get that right, everything else that is built on top of that all is going to fail, right? Because all of our software, our complex automated systems for doing workflow and solving problems in a semi-automated to fully automated way, software, is built on the data, which is defined by our data model. So if that foundation is wrong, the whole house is going to crumble. And that's why I'm really interested in data modeling. And it's one of the reasons that I really, really like graph databases. So let me dive a little more into exactly what I mean by that. And let me show you. All right. So here's probably a fairly familiar picture to many of you. This is an entity relationship diagram, an ERD, for a relational database. Many of you probably recognize this as the now famous, or perhaps infamous, Northwind database, made popular as a demo database and a learning database by Microsoft many, many years ago, and is still alive and well with us today. So this is a graphical view of that, a picture of the Northwind database, the whole data model. And Northwind, right, is about modeling employees and products and customers and orders and how those things are shipped to customers. So it's a fairly simple, you could think of like a retail or a sort of a supply side model or custom or problem domain. And Northwind, by design, is a really simple database, right? It's designed to teach people how to use relational databases and do things on them. So it's pretty simple. I think most of you would agree, if you've done any sort of work with relational databases in the past, that anything you've put into production for any kind of sizable system is probably much more complicated than what we see here. But let's talk a minute about what we see here. One of the biggest challenges is this is somewhat difficult to understand, particularly for the layperson. Right? So again, my premise is that if I cannot, as the engineer, clearly communicate to the customer what the data model is, make sure that I understand it in the way that the customer understands it, because again, it's their data, typically it's their data, they're the domain experts. If I don't understand that to the depth necessary to create a good model, we have a problem. So the customer explains what's the data model. I capture that in some way. In this case, it's in a relational database, and I have this picture, and I want to present that back to the customer. And for any of you who've gone through this exercise and tried to do it with this, this is challenging. You put this on a whiteboard, or you project this rather, and people become intimidated, and rightfully so. It's kind of hard to follow. And this is a fairly simple one, right? So I can see, for example, that customers appear to be connected to orders. That makes sense. But then there's this customer demo thing that is tied between them and orders. Sorry, it's over here between them and demographics. So it's that's a little bit confusing for me, right? I mean, as an engineer, I understand that this is a many-to-many relationship, but as I try to explain this to stakeholders, I start to gloss over and so on, right? And again, this is a very simple model. As we have much more complex ones, it can be more and more difficult to convey information about them and have that good, clear communication with customers. And again, if we can't do that, I can't validate this model. I don't know if it's right. What happens? We go out, we build something on top of this, we start showing some demos of that, or maybe even worse, maybe go to production, and then the customer starts having questions. It's like, whoa, why is it working this way? Or why does my data look that way? Or why can't I get this answer to this question I want? And when you dig into that, you find out, oh, we've miscommunicated. I've misunderstood how the data is supposed to relate or supposed to be modeled. And now we've got a lot of work to do to fix that. So that's a challenge with relational databases. Others as well, but this is the one that I think most people are most familiar with. It's still by far the leading database technology in the market. So I'm going to pop over to something where we can talk about modeling a graph database. And let me just open up my screen. So I'm just bringing up a tool here. This particular tool is one that my company produces. I'm not here to demo this tool for you. I'm just going to go ahead and use this at the moment because it provides me a nice canvas to do some modeling for you. And that's what I really care about today. So what we're going to do here is we're going to start talking about different modeling concepts, how to model them in a graph database way, and try to infer some rules from that as we go. So we'll capture those rules hopefully over here. And the first rule, I think, which is the most important rule perhaps, is really there is not a single correct model. And this is really important, right? And it's important because we all want there to be a single source of truth, particularly engineers, right? We like to be correct. We like to be right about things. If we can say that this is the way to do it, it's the only right way, that makes things a little bit easier. But what I'm going to tell you is there's not just one right way. There's often choices that can be made, and depending upon different circumstances, depending sometimes on a little bit of your personal preferences regarding some style or some semantics, more than one answer can be equally valid. It's not to say that all models are correct. There are definitely wrong ways to do things, but there's definitely art and understanding required to create a good database model, and not just a single way to do that. So, with that being said, let's look at some possibilities. Let's sort of stay in the realm of maybe that retail type of example that we had in Northwind, so that we can one have a be in a domain that kind of everyone can relate to, and we could compare it potentially a little bit to what we had in Northwind. So I'm just going to put some things on the page here. So I'm going to say I want to have a customer, and let's start out and say that we have products. So as you can see here on the right, again, I'm just creating those nodes that I'm going to use for my model. Kind of just like drawing on a whiteboard. But if you were here with us last time, you've noticed that my drawing is not that great. So this is going to hopefully give us all a much cleaner picture to deal with things versus watching me kind of scribble around and try to draw things. And let's just say for a moment that a customer has they live somewhere, right? So we'll call that an address where they live, and let's just start there for a moment. So one of the things I like about graph-based modeling is it should feel very intuitive. I think a lot of us have been doing graph-based modeling without ever knowing it for a large portion of our lives. If I were to sit down with any of you and ask you about your business or one of your favorite hobbies or interests, to really explain that to me, and we had a whiteboard with us, odds are high that you would go to the whiteboard and you would start drawing things out, and you would draw some version of circles and lines connecting them. Well, that's a graph. It's very natural in terms of how we think about things, right? So I know that a customer, I know the customers, it says, has a home address. So again, just kind of drawing that out so we can see that here. And that makes sense, right? Customers have a home address. And customers, again, because we're in a property graph, I can put properties directly on them. I don't have to model them as other relationships to things. So let me just put some basic information in here for a customer. I'm just going to say, for example, maybe a customer has a full name, and we'll say that they have a gender and that they have an age. And that's a good start. Right? How about a customer ID? Because I know that these are all customers. By definition, I've probably given them some sort of internal ID. So that's lovely. So now I've got customers. They have an address. Again, with address, we can add all of the familiar things that we were thinking about typically. So it's street address. So we've got a street address. We've got a city, a state, and a zip code. And because it will bother me, we'll get rid of that extra S in city. Lovely. So the customers have a home address, and we've defined what a home address is. Now let's consider email address, for example. Customers have an email address. I want to email my customers about things, promotions. They'll be emailing me with customer, either with order questions, or perhaps they have some customer care concerns. I definitely want to capture the customer's email address. So that kind of brings us to our first question, which is, where do we put email address? Right? There's a number of ways to think about this. So I quickly threw up in the beginning of this customer and products and address to kind of kick this off and get us started. And if you look at these, you can see, well, these are obviously physical things, right? or at least concepts, right? You can reach out and theoretically, and you could touch a customer, not during COVID, but we understand a customer is definitely a thing. It's a person, it's an entity. Same thing with a product, right? It's a physical thing. Address, right? We understand an address is a unique thing into and of itself. It is where something is located. It makes sense to kind of have it as a core entity in our data model, right? We think in things in terms of addresses, and that's kind of how we're going to start grouping things. If we think about if the way we naturally think about whatever it is we're modeling as its own physical or conceptual thing, sort of separate and having almost a life of its own, then typically it becomes a node. So you might be tempted to say, well, email address, right? So an email address, and that we could say, customer has an email, and that email address, of course, has a, maybe as an address. And that would seem, at first pass, just to be a reasonable way to do this. However, let's look at email address. If all we're really interested in is the actual email address that a customer has, because I want to send them a message, or I want to know who sent me a message, and all we're capturing really is that one address, there's not much inside this entity, right? There's not much information in this node. I've got a node sitting out there by itself that's only ever going to have one thing in it, and that's that email address. And the picture looks pretty, and it's easy to understand. But should we really have address all the way just sitting over there? And what I'm going to tell you is as a general rule, and we're going to butt up against this very quickly, is no. As a general rule, when you're doing graph modeling, if you come up with a node, like email address, that only ever has one property, like address in this case, generally speaking, it should probably be a property of the thing it's associated with, rather than its own thing. Oh, so if you hear that, I have dogs. So let's see if I make this work. I have dog cam today. I promised that a little bit last week. So let's see. There we go. There's dog cam. So that's the barking. She's guarding the house. That's my 2-year-old German Shepherd, Sona. So she's now famous on Twitch. She doesn't even know it yet. So you may hear her again. Hopefully it won't be too bad. All right. Enough for the premiere of dog cam. It was exciting. But yeah, so it should probably be a property, again, of the thing it's associated with. So that kind of gives us our next rule, which is, and I'm going to call these things entities. They're really nodes, right? Entities and nodes, kind of the same term for thing, that only have a single property should usually just be a property of the thing they are connected to. Right? So why is that? There's a number of reasons, but for the most part, they have to do with how queries are going to be resolved. And while I did tell you that we're doing this because I'm not very great at drawing, I'm going to prove that to you, and I'm going to draw some more things for you right now so we can kind of delve into that. So let's hope this goes well. Let me create another page over here so that I can do some drawing. Alrighty, let's draw some stuff. And yeah, that's a pencil. There we go. I need it bigger. It's probably big enough. All right, so let's just draw sort of a pretend graph, right? And there's node, the node, and we'll draw some other nodes. All right, so we're going to draw. It's obviously going to be a fairly simple graph because I'm not going to draw a million nodes here. But let's go ahead and connect these, perhaps in this manner here. And as you can see, even with a drawing tablet, my drawing is trash. It's getting better. Well, it's not entirely true. I'm getting better with the tool, but my drawing is always going to probably be bad. Okay, so there's a pretend instantiation of a graph database, right? So let's say all of these things are nodes and relationships in our graph database containing data that we're interested in. So, as I said in the very beginning, there's not always one way to do a model. And while generally speaking, I think we always want to strive to do a model that is conceptually easy for our customer to understand and for us to communicate with, and that correctly models the data. Correctness is, of course, extremely important. We also need to bear in mind the realities of the engineering side, in this case, potentially performance. So meaning there could be a scenario, and we're talking about one of them right now with this email address, where modeling it as a node versus a property might conceptually be essentially equivalent. You get into maybe some stylistic differences. But the question then becomes, is there an engineering advantage to one versus the other? And unfortunately, like most things, the answer is sometimes. And to know when, we have to understand a little bit about how queries are resolved. I'm going to be a little fuzzy here because obviously the exact details about how your graph database resolves your queries is very much dependent on the implementation of your graph database. Thank you, by the way, for the kind comments on the dog. I would definitely pass those along. You might see my other dog later, hopefully not, but potentially in a different stream. So again, each graph database will do it a little bit differently, but generally speaking, when you create a query, the first thing the database engine is going to do is going to figure out where to start looking at the graph. Remember, so what graph databases are really good at is traversing relationships, right? So walking out those relationships. They're really, really good at that. Let me draw it over here as well. Okay, and that's what they're really good at. They can go from here to here to here to here millions of times across lots of data really, really fast. That's why we use graph databases, to understand the analysis between different relationships in our data. But to do that, right, so to get from here and figure out how can we get to here or can we get to there, we have to start somewhere. So if I have a query, for example, that essentially is asking to find all customers that are female and in the age range of 18 to 30 that bought a product that is in a certain category, and then give me that person's home address, the first thing the graph database needs to do in order to evaluate that is figure out where do I start walking the graph, right? I've talked about in that pretend query about customers, I've talked about products, I've talked about addresses at the very least. So where, if I have a customer who probably have a transaction, right? So if I have a customer who made a transaction for a product, and that customer is in a certain demographic, maybe the demographic information is stored in the customer, I want their home address. So I've got to walk a bunch of nodes. But where do I start? That's the first thing the engine will typically do, is it's going to figure out where's the most efficient place for me to start my query. And of course, where that is going to depend heavily on your implementation, what data is in your database, etc. But the key thing is it figures out where to start, and then it goes and it walks. So this might be customer, so maybe it starts here, and then it walks over to transaction, into product, and to maybe the brand that the product is in, and then it comes back over here, and it gives us the home address, which is maybe related down over here to it. So it's gonna do that walk, say, oh, this is a customer that matches that information I asked for, the customer demographic information, and yes, did they make a transaction? Yes. So I'll walk all their transactions, and is the transaction for the matching product? Yes, it is. And is that product in the correct brand? Yes, it is. Okay, great. Now I go back over here and I find the address, and that comes the result of my query. Right? So essentially, again, super high level, that's how a graph database is going to resolve your query. Step one, where do I start walking the graph? And then step two, go ahead and walk the graph. And then that part tends to be very, very fast in a good graph database. And again, the exact implementation details are certainly going to vary. So, why did I give you all that background? Because it's relevant to what's happening here. So if I want to find the email, if I want to find someone with a particular email address, let's just say, again, if I get a customer email, and I want to get an email for customer, and I want to know who sent me this email. If I model email address this way, the system can find that email address, no problem. It'll find all email addresses that match that, probably one. And then it's got to walk once over here to give me the customer. So it's going to do a lookup, find the node. It's going to traverse this relationship. And yes, I know the relationship is showing going from customer to email, but typically speaking, graph databases have no problem traversing the relationships in either direction. And then it's going to grab this customer and give me the information I wanted. Not a big deal. One node lookup and one hop. But of course, in more complex relationships, that's a lot more hops. If I'm actually looking for customer information based on, again, maybe their address or some kind of transaction they've done, and then I want their email address, I might be pulling back a lot more customers. And so now, number of customers I'm returning times one extra hop and an extra node lookup, it's a lot more work. So at scale, that becomes more. So I'm doing more work here to get email address for customer, and I'm not really gaining anything. If this customer only has one email address, I'm not going to gain anything. It's much easier if this email address was embedded inside customer as a property. So I went over here and said that email address is just a property on customer. Now once I've either, if I just want to find the customer, I can look up the customer directly by email address. Doesn't have to walk any relationships. Or, again, in a more complex query, I'm finding customer based on some much more complex algorithm and maybe pulling back many customers. I don't have to do those extra traversals and node lookups again to get the email address. It's right there in customer. And the understandability of it is not really impacted. Right? It's easy to understand that a customer has an email address property, just as easy to understand as this. You may prefer seeing it this way in the picture, and that's fine. But in that type of modeling, the performance could be an issue at scale when you can have a node that only has a single property name. So that was that rule. Now we're going to talk about the exception to that rule, which again is going to be email address. What if my customers have more than one email address? I have many email addresses. I have several actually for work. I have several for personal use and other organizations I'm involved with. If I'm a retailer, I probably need to respect that, right? The odds are very high that if I've interacted with Amazon or any other online retailers, I've got more than one email address associated with my account. And so if I, as that business, I need to be able to track that. So now, that brings us to, let's bring back to our page with our rules on it here. That brings us to sort of the exception. So we'll make that maybe 3A. And we'll say, however, if the entity may have more than one of the related thing, then it makes sense to keep it a separate entity I could type, I could do wonderful things. Instead of, I cannot type. Instead of a property. So, my customer may have more than one email address. If I make email address a property here, that becomes more complicated. It becomes harder to model. Now again, your mileage may vary. Some graph databases will let you say that the email property isn't just a string, for example, but is a list of strings or some other container type data structure. So you could do that. You can say, oh, it's a container type data structure, and I'm going to do that. Yes, you can. What I will warn you is, regardless of the implementation, your querying of that typically becomes a lot more complicated. A lot more. Queries that have to grab an entity like a customer, grab a property on it, treat that property as some sort of collection or larger data set, and find something inside of that tend to be harder to write and often will therefore not perform as well. Again, your mileage may vary depending on your implementation, but this tends to be more difficult. So I'm going to get rid of email address as a property here, and we're going to leave it as we first drew it. So the customer can have an email address because they may have many. So, but what if I want to understand the type of email address? So I have a, and let's do that with something very similar. Actually, let's do that with phone. Phone number, all right, is very much like email address in that it typically only has one property. Now, yes, we could break that up into like area code and prefix and so on, but I'm not interested in being that pedantic about things in this particular example. So I'm going to say customer has phone number. And again, like email address, I typically see people having more than one phone number. I've got a cell phone. I've still got a landline. I maybe have another cell phone for my work number, whatever that might be. So, but this will allow a customer to have multiple phone numbers, but it's not differentiating them, right? So the question becomes, how can we differentiate them? So there's two ways to do that. The number one way I typically see, and again, your mileage is going to vary a little bit. So this is going to be a case where you're going to have to understand your database implementation and how that actually works to maybe pick the best one and understand your use case. But here are a couple of good ways to do that. So option number one, of course, is do nothing and just not differentiate it. But if you have to, what you'll see a lot of times is I'll put a property on the relationship. Nice thing about properties, property-based graphs, is you can put properties on the relationship as well as on the node itself. So I'm going to call this property maybe, we'll just call it type. So what is my type of my phone number? It could be a mobile, it could be a work, it could be a home, it could be whatever. So that's a reasonable way to do it. You'll notice one drawback here now is that while I can query for that, I can say I want to find a customer that has a phone number, that has a particular phone number, where the type of that and that has phone number relationship with the property is equal to this type. And again, depending upon your implementation, that may perform just fine. But now as I'm sitting down and I'm talking to the business and we're talking about this data model, it does become a little bit harder to see that, oh no, I did do phone number by type. I've got to kind of show them in some way that I have this property there. Not a huge deal, not a huge drawback. Certainly one valid way to do that, and tends to be the sort of the most natural one I see people gravitating towards. Other possibility, you can put the type onto the phone number itself, right? So right on phone number, I can put the type, and so in here I could say this phone number is a mobile phone, or it's a cell phone, or it's whatever it might be. That might work okay in your domain. Maybe you could run into some odd issues where this domain is a shared number, whether that's a household phone for maybe my wife and I, or it's like a trunk line for a business. So maybe my wife considers this landline her home phone number. Maybe I have an office chair and I consider that a work number. So now that could be a little bit problematic, but in a lot of cases you can do this. The third way, which is the one I tend to like personally, is I like to create another relationship. So I'm going to say maybe has mobile phone, and I'm going to rename this to as home phone. So now we can see I'm creating different types of relationships to this phone number concept. Has mobile phone, has home phone, has work phone. In a lot of graph databases, this may give you a significant performance advantage, as you don't have to walk all the way out here on a query to figure out what kind of the phone number this is. So again, if the property's on here and I want to find customers, a home phone number, I have to walk all the way to all their different phones and find the one which type matches. That can have a performance impact. Here I can typically just query by the relationship type and only pull back the ones I care about. And it's a bit more semantically clear in my view, in terms of the modeling. So we can very clearly see that I have a fixed set of options, essentially: home phone, mobile phone, work phone, perhaps, versus more of a nebulous type that is not in itself constraining. Sorry, yeah, text. So let me see if I can do this. I apologize. I have not. Let's see. I am trying to get, hopefully that's a little bit better. I apologize. I am trying to get better about keeping one eye on that chat. So if I didn't see that in time, hopefully it's a little bit easier to see now. So yeah, this is more of an explicit model, right? I've constrained the number of possible types of relationship between customer and phone, and it becomes easier to see. So let's just sort of, and let's make that bigger too. Whoopsie. There we go. And I don't know why I can't make this all bigger at once. It's a little frustrating. I apologize. It's probably even more frustrating for you. All right, so when modeling relationships with different types, think type of phone, consider explicitly defining the relationship, the type, as a new type of relationship versus a property. This is a type versus a property on the end node. And for, again, clarity, in this case it was phone, or a property on the relationship. So when we modeled those relationships, I think different types, like has home address, has business address, has home phone, has cell phone, has work phone. Very often, explicitly creating a different relationship type can provide you not only with a performance enhancement, but with a clearer model. I know we're a little over our normal time. I'm going to go just a tiny bit longer and talk about really just one more concept, I think, today, so not take up too much time. And then I think we're going to expand this and talk about more of an in-depth sort of advanced modeling concept next week, and I'll give you a preview of that in a second. So here, and we'll keep those rules, and we'll kind of keep running with them. Maybe I'll even clean them up a little bit. So here we've got, again, a customer has an email address, a home address, and potential different relationships to phone numbers, home phone and mobile phone. And so we're good with that for the time being. Pardon me. Let's just talk a moment about the direction of these arrows for a second. And to do that a little better, let me add one other item to our model. Let's just say, okay, transaction. So you go to a store, you buy something. You go to the store. So you go to the store, you buy something. That's a transaction, and that transaction typically contains, if you look at your receipt, a line item, right? So and that line item has a product in it, typically a price and so on, right? So if you think of the transaction as the entire receipt, the line item is each individual thing that you've bought on it, right? Customer makes a transaction. And now we can, now the question becomes, what I want to talk about here is the direction of these arrows, right? So I'm saying the customer makes the transaction. I typically see people do that. There's the dog again. And then we can say that that the transaction perhaps has a line item. Or we could say, and then we get to connect products, and we could go this way maybe. All right, so let's talk about a couple of things really quickly. As I mentioned, typically the direction of these arrows does not matter at all in terms of your query performance. Again, mileage may vary depending on implementation, but typically speaking, in your commercial class of property graph databases, these directions do not matter. It will matter that you, when you query, you specify a direction you want to walk, but you can always walk them in either direction. So even if I say, again, this relationship from customer to transaction goes from customer to transaction, you can still query it from transaction to customer. Not a problem. But again, as we're talking about this, as we're reasoning about it with people, I think it makes a huge difference. And this is a bit of a personal preference, but I'm a really big believer in trying to model things in the most natural way. So again, I think a customer and the relationship with the customer transaction, I make the transaction. Right? The transaction does not in some way control or define the relationship to me. I as a customer do. So I like to create the relationship in that direction. So the customer here, and again, I also like to, you'll notice, word them in a way so as you're reading this, you're talking about this to people, it flows naturally when you're talking about it. I have customers make transactions, and those are transactions. A transaction has a line item, right? So that's a thing that is on that receipt, is physically on there. You will see sometimes people want to go in the other direction. Let's say, a product is, it is the line item. This is the line item for a product, or a product. We'll call this maybe, product inline item. It starts getting kind of engineering-y. I'm not a particular fan of that. I think it makes it harder to understand again. And here again, to say that the product is going to the line item just doesn't really flow for me naturally, right? If you think again about the workflow, the business flow of this process, I make a transaction because I've bought something, and defined in that are these line items, and those line items say this is the product for which which has been purchased. So I would even say it has product and go in that direction. So if I talk about this entire workflow and I'm making sure that it matches how my customer thinks about things, I can say to them, I'm gonna make sure I get this right. I see that customers make transactions which have line items, and each of those line items has a product. Is that right? And that's really, really easy to follow from the concept of the business. And it makes no impact on the engineering whatsoever, but it makes the understanding 100% simpler in my experience. And this simplicity in modeling is one of the absolute key things that I see in dealing with customers, is getting past that barrier, getting past that hurdle, and making sure that we're communicating clearly about the same thing. I'm going to save this very quickly here so that when we come back next time, I can still have this and we can talk about it. And we can expound upon this. Because my last point there on clarity, I do want to show you something really brief, and we can talk about this more next time. Let me just posting up. I've been having odd computers today. We had some storms last night, and my computer's been behaving very, very oddly. So perhaps I'll show you this next time, since we are over as it is. So hopefully, let's get our last rule in place. Try to create models that flow naturally. Oh, here we go. Dog cam number 2. I promised you a second dog. And okay, there's my other German Shepherd. That's Guinness. Say hi, Guinness. Hey, buddy. Say hi. Dog cam. All right, there he goes. Bye, dog cam. Alrighty. Try to create models that flow naturally when spoken out loud. In order to create clear communication. That's really, really important in my mind. So we'll come back to this more next week. We're going to go deep into some more difficult scenarios on modeling. And again, I certainly look forward to all of your any questions you might have. Please feel free to send them to me on social media, via email. We're on Twitter. I'm always looking forward to that, and I want to definitely address the issues that are important to all of you. And thanks. I appreciate you all coming. I'm Clark Richey, and I'm the Graph Guy.